Now, 13 is a person leaning against the wall. And when you lean against the wall, if there was no friction at all, this person's feet would move in that direction and the person would slide down the wall because of their weight. They because of the weight over here. Do I have everyone looking at here? If that's where my pivot point is, and that would be making it go like that. So in order to create that type of a rotation, this person would slide down the wall. And so I need friction in that direction to keep them from sliding in that direction. Now, normally, you would also have friction here because the shoulders are touching the wall. So when this person slides down that way, the shoulders would slide down the wall. So if there was friction, then friction would be up at the shoulders. But it does say in the problem that it's a smooth vertical wall. The key word is when they say smooth, that means no friction. They could have said frictionless, but also sometimes that's like the key word. Like if they say smooth, it means that we're not considering any friction between the shoulders and the wall. So I'm going to make, since it is a picture here, I'm going to make my free body diagram just with lines. So this is going to be my, whoops. This is going to be my wall. I'll try and make it so it lines up. That's going to be my floor. And then this line that I'm drawing is going from shoulders to feet. So that's my line. And the center of gravity is right there. So I'm going to put it on the picture. And I'm going to have that in this direction. So it's going to be like that. That's the weight of the person, the center of gravity of the person, that's its location. There's also the normal force. Now in labeling the normal force, I'm going to actually label it. I know it has it right there, but I don't want that to get in the way. So I'm going to label it down below. So I'm going to label that Fn. And this person, okay, so the weight, I know I'm going to label it down there. So the weight is 500 newtons. Now, the other force, yes? How do you know that the arrow for the weight points down? Because weight is always straight down. I mean, the person, the earth is down here, so you always have the weight straight down to the earth. Now, remember, there's also two other forces on this picture because you're going to have, and I'll do it in a different color because it would be tough to see. I'll just do it in green. You're also going to have the ground in the x direction would be like that, which is really the friction. So the friction on the feet, which keeps the person from sliding, would look like that. And then this would be the GY. So, I mean, I'm calling it G because it's ground. So you can call it whatever you want. If you want, you can say that that's friction and use the italics F and call that normal force 2 and then call that normal force 1 because that is a normal force. This is a normal force also. But I'm just going to label them as the ground because if you look at the problem, they're saying in part B, the horizontal and vertical components of the force exerted on her shoes by the ground. So the ground has an X component and the ground has a Y component. But like I said, the X component is really friction, and the Y component is the normal force between the feet and the ground. And if you look at the picture, notice that once I already know what the weight is. There's only 4 forces on this picture. So I already know what GY is. What will GY equal? If this is my picture, what does GY have to equal? 500 newtons, because if that's 500 newtons, that has to be 500 newtons so that it doesn't move up or down. We know this person isn't moving at all. So not only are they not rotating, but they're not moving up or down, and they're not moving left or right. So I will know what that is. I already know what that is because there's only two forces in the y direction. I also know that once I figure out what that is, that's going to be what that's going to equal. So I don't even really have to do any work to get part B. Once I know the answer for part A, I'll know everything for part B. So if I give you this on the test, I'm probably just going to ask you, what's that? I'm not going to ask you this. But if I'm going to use as my pivot point, I'm going to use this as my pivot point right there. Because that eliminates two of the four forces on the picture. Because both of those arrows go right through the pivot point. So now I only have to worry about these two. And both of these I have to break into components because that is not perpendicular to the line between the feet and the shoulders, and that's not perpendicular. So I need to take both of these and break them into their perpendicular components. So I am going to take the weight, and the weight, that's going to be its perpendicular component. I'm trying to make that perpendicular to the line there. And then this one, perpendicular to that, would be in this direction. All right, so also notice that the components are always smaller than the full vector. So don't ever make this go like all the way to there. That arrow has to be smaller than that because the components are always smaller. So there's my picture, and I'm gonna sum up my torques now. I didn't label a lot of stuff on the picture. I'm just gonna use the picture. Well, one thing I should put in the picture is this is 60 degrees here. So if that's 60 degrees, then I know that is 60 degrees. Now, what do you think the angle is right here? What's the angle right there? 30. Because if this is 60 degrees, that's 60 degrees because they're alternate interior angles. So if that's 60, that's 60, and these two are complementary. So I know that that angle right there, I'm not going to try and squeeze it in there because I can't fit it, is 30 degrees. So, summing up my torques. Now, if this is my pivot point, is the normal force from the wall? That's counterclockwise. So counterclockwise means plus. So it's going to be plus Fn times what trig function would I be using to get the red? Cosine. So Fn cosine 30 degrees times its distance to the pivot point. I didn't put those numbers on my picture, but they're on the other picture, so what would it be? 1.5. Right, 1.50 meters, because it's not on this picture, but over on this picture, from there all the way to there is 1.50 meters. Now, the other one, is this one making it go clockwise or counterclockwise? Clockwise, so that's going to be minus. So it's going to be minus 500 newtons times what trig function? Cosine of 60 times its distance to the pivot point. What's that? 110 meters. And that equals 0. And if you can get to this point in the problem, I know we're running out of time. If you can get to this point in the problem, you've got the answer. Because you're just going to move this whole thing to the other side, because it's minus, and then divide by the cosine 30 and the 1.50 meters, and you'll get the answer that I gave, which I think was 212 newtons.